So we introduced the word amphoteric this morning. Water is amphoteric. It can act as an acid or a base. And this is really kind of crazy. In pure water, water can act as an acid and a base with itself. So this water molecule can say, well, I feel like I'm an acid today, and I'm going to donate a proton to that guy who feels like he's a base today. And then we end up with a hydronium ion and a hydroxide ion. This is called self-ionization. It ionizes with itself. It happens to a very, very small degree. Because you might say, well, why would it do that? I thought nature liked to make things equal. The water molecules are the same. Why would one give a proton to the other? It doesn't happen very much at all, but it can happen. Happens to a very, very small extent. And so in pure water at room temperature, we end up with the hydronium ion concentration being equal to the hydroxide ion concentration, and they're 1 times 10 to the minus 7th molar. That's very, very small, isn't it? It's a decimal point, 6 zeros and a 1 moles per liter. Very, very low. The concentration of water in moles per liter, if I remember correctly, is about 55 moles per liter. So it's a huge difference. And if we look back at this equation, we see that for every pair of water molecules that do that, we're going to get one of these and one of those. So in pure water, these have to be equal, because if you get one, you get the other. So they are equal. That's an equilibrium, and for an equilibrium, we can write an equilibrium expression. Here, instead of KEQ, it's called KW. It's called the ion product constant for water. It's the same idea as an equilibrium constant. It's the concentrations of the products multiplied by each other and divided by the concentration of the reactants. Why is there no reactant in there? Because in this equation, the reactants are liquids. And liquids and solids are not included in ionization expressions or equilibrium expressions. So Kw equals hydronium times hydroxide ion concentration. The value of Kw is 1 times 10 to the minus 14. That tells us that the reaction favors the reactants and that there are very little of those products formed. So if the hydrogen ion concentration has to equal the hydroxide ion concentration, then we find that they're both 10 to the minus 7. So in a neutral solution, we have the hydronium ion and the hydroxide ion being equal, and the concentration of each of them is 10 to the minus 7. So these concentrations are equal, 10 to the minus 7. If we have an acidic solution, if we add acid, then the hydronium ion concentration will be larger, and the hydroxide ion concentration will be less. Because remember that equilibrium constant is the same. It's always 10 to the minus 14. Let me write that in here. So Kw equals, just for short, I'll call it 10 to the minus 14. That's the hydrogen ion concentration times the hydroxide ion concentration. So if this one goes up, then that one has to go down in order for them to still be equal. In a basic solution, the hydrogen or hydronium ion concentration will be less and the hydroxide ion concentration will be high. But in all of those, the hydronium times the hydroxide is 10 to the minus 14. So there's an interdependence. If one goes up, the other goes down. So here this end is acidic. The hydronium ion concentration is large, and the hydroxide ion concentration is small. And as it's a little bit like a rope. You throw a rope over a tree branch, and you can hold it so that both ends of the rope are the same. But if you make one longer, the other one gets shorter. And if you make that one longer, the first one gets shorter. And it just has to happen that way. I'm not going to do all these examples. Let's just do the first one. calculate the hydronium ion concentration in each solution and decide if it's neutral, acidic, basic, or neutral. So we're going to use that Kw expression to do this. So Kw equals the hydrogen ion times the hydroxide ion. And that was 1 times 10 to the minus 14. So we did calculations like this in chapter 15. So if we want to find out what the hydronium ion concentration is, or the hydrogen ion concentration, we're going to divide, we have to rearrange this equation and solve for the hydrogen ion. Remember, hydrogen ion and hydronium ion concentrations are essentially the same. We use them interchangeably. Those cancel out. So then we have that the hydrogen ion concentration will equal 1.0 times 10 to the minus 14 divided by the hydroxide ion concentration. 1.5 times 10 to the minus, close, times 10 to the minus 2. Here's another place where if you're not using your EE button on your calculator, you can get into trouble. 1 EE minus 14 divided by 1.5 EE minus 2 equals, in my calculator I'm going to use two significant figures. It's going to be 6.7 times 10 to the minus 13 molar. And just these numbers are of a size that you just cannot always convert them into decimal form and type them into your calculator that way. So you really do need to learn that EE button. Any questions about that one? Yeah, so make sure that you can get this number to show up on your calculator. So I have a TI-30XA. And there are other calculators that use a different form of logic. So if you have a different one, just plug your ears and say la la la. But on the TI-30XA, so 1.0, and then press that EE button. Not times 10, because EE stands for times 10 to the. So 1 EE, and then I'm going to do the change sign button and 14. So now I've entered 1 times 10 to the minus 14. Then I press the divide button, and 1.5 EE minus 2 equals. And my calculator shows me 6.66, a whole bunch of sixes, times 10 to the minus 13. It was giving a negative 17. Is it doing it okay now?
Yeah.
Okay. Yeah, if you're doing something funky like putting in times 10 to the, and then pressing, sometimes students want to do 1.0 times 10 EE. And sometimes it works out okay, and other times it doesn't. But what you're doing there is you're adding in a factor of 10 to everything, and you're separating that number. You're telling your calculator it's actually two different numbers, and so then it gets its order of operations all messed up. So if you're not getting the numbers on your calculator, please talk to me. It's a very, very small glitch that you're having, and it's a shame to lose that many points on an exam just because of a little glitch.